This is number 5 in the list of worked examples highlighting the application of the precedence formula F DUAP. Here, the example says 4 bracket 5 over 2x minus 3 minus 1 over 2 is equal to 1 whole number 1 over 26. We take it as a given equation to be solved. Before we proceed, we have to ask ourselves first, out of this DUAP, that is DUACP, which skills, which of them will be needed for solving this equation? Okay, it is D, U, A, and C, which means that there will be a need to make a divisor become 1. See divisors here, 2, 26, 2x minus 3. They are all divisors. And even if some are 1, all are not 1. Therefore, there will be a need to make the divisors become 1. What about U for unification? There will be a need for unification. Right now, you may not see the need because you see the x appearing just once in the process. But as time goes on, you will see that x will now appear in more than one place, making us need application of this U, that is unification. That means that it's going to be a place we unify by means of collecting like terms. What about other? We might have many others, but the most permanent here is this minus 3, which might not remain minus 3 throughout the process. But with this equation, we see that minus 3 is the adder to this x. Therefore, there is going to be a need to remove the adder. Whether it remains only minus 3 throughout the process or not, we have seen that there is going to be a need to make an adder become 0. What about coefficient? The unknown here is x. Right now, we can see that 2 is its coefficient instead of 1. Therefore, in the course of solving this equation, we are going to need converting this 2 to 1 to make it the x coefficient. The power of x is 1, and that is why this p here will not be necessary. It is only DUAC, that is DUAC, that we're going to carry out. That means that there will be 4 different and important steps of solving this equation. It does not mean that in all there will be 4 steps, but there will be 4 major steps, 4 major skills needed to be applied in solving it. Now that we have known the skills we are going to apply in solving it, let us start solving it. Now look at this second line. What is happening here? What is happening is that we modified the equation to make it easy for us to solve. 2 things happened here that make us believe that that equation was modified, that this equation was modified to become this. First, watch this 1 whole number, 1 over 26. It has become 27 over 26. I believe that you can convert this kind of mixed numbers to an improper fraction, 27 over 26. 1 over 2 remains the same. But this 4 bracket 5 over 2x minus 3 has become 20 over 2x minus 3. Do you wonder why this has become this? Anyway, it is not compulsory that we convert this to this. But before I say anything else, let me say that since this has become this, that is something that led to it. Before we talk about now, having known the skills that we're going to apply in solving this equation, let us proceed to solving it. The next line, which is this one, shows that this equation has been modified. That is, this equation has been changed or treated to become this. No value has changed. Everything remains the same thing. It is just that they have been expressed in different ways to appear in forms that will make it possible and easier for us to solve the equation. First, for me to mention is that this one whole number, 1 over 26, has become 27 over 26. I hope that you know why this is written in this form. This 1 over 2 remains the same 1 over 2. And now this expression has become this one. How did this become this one? Simply, we remember that 4 bracket 5 over 2x minus 3 means 4 times whatever the thing that is contained in the bracket. That is 4 over 1 times this over this. It is as if we're multiplying a fraction by a fraction. And we remember that if we're multiplying fractions, numerators multiply to get a single number or term. Similarly, denominators multiply to get a single term or number. That means if we have 4 over 1 here times 5 over 2x minus 3, the numerator here is 4 and the numerator here is 5. Here, its denominator is 1. Here, it is 2x minus 3. Then let us use the principles of multiplying fractions in simplifying this. We now say numerator times numerator, that is 4 times 5 is 20. Then denominator times denominator, that is this 1 times 2x minus 3 is equal to 2x minus 3. Don't forget that it is not 2 alone. It is not x alone. It is not minus 3 alone that is called this denominator in this bracket. Instead, since this slash covers all of them, then it is 2x minus 3 put together that we refer to as denominator in this bracket. I hope you now know how this expression became this. It is by the application of the formula for multiplying fractions. Therefore, we now have 20 over 2x minus 3 is equal, 20 over 2x minus 3 minus 1 over 2 is equal to 27 over 26. We now see how this became this. This is compulsory that we change it to this, but this one is not compulsory that we turn it to what we have here. This is by preference. Why? We can clear fractions. We can make divisors 1. And this 2x minus 3 is not going to be seen as having an obstacle. But this 26 as one whole number, 1 over 26, will not be easy to be treated when it comes to making divisors 1, because this 1 here is one whole number. That means it is separate. To combine it with this one, we must convert it to this improper fraction, which is 27 over 6 over 26. 27 over 26 here. like I said earlier, we can proceed without necessarily converting this one to what we have here. This 4 will not be an obstacle to making this divisor, which is 2x minus 1 minus 3, become 1. Which means that 4 is not an obstacle, and this bracket is not an obstacle. Why? Even though this 5 over 2x minus 3 is enclosed in a common bracket, the power is not more than 1. It is when the power here above is more than 1 that it becomes practically impossible to look at this 2x minus 3 as a free denominator. But as it is, since it has power 1 mathematically and as discovered during experiments, this 2x minus 3 is regarded as free, a free kind of denominator, and it's not going to have any obstacle when being removed. Now we have it this way. What do? We go back to the first scale, which is this D, to make that all the divisors become 1. 2x minus 3 is not 1, but probably, because we don't know what this x is. But as long as x is not known, we assume that this 2x minus 3 is not 1, this 2 is not 1, 26 is not 1. None of the divisors is 1. Even if there is 1 as a divisor, at least as long as there is one of them that is not 1, it is just right and agreeable that we apply the method of making divisors become 1. So how do we make these divisors become 1? As before, we choose the LCM of the denominators. But the question now is 2x minus 3, 2 and 26 are the divisors or the denominators. Though this cannot be called denominator, it is better we call all of them divisors. Therefore, what is their LCM? Remember that I said earlier, perhaps not in this topic, it was at the time I was discussing fractions, that it is not compulsory that the common multiple is the lowest one. Any common multiple can serve. Any common multiple can serve. What it means is that the simplest of the common multiples we can get can serve. The simplest may not always be the lowest one. The simplest multiple anybody can use in a case like this is the product between them. For instance, if I am looking for the common multiple of 2 and 26, we know that it is 26. Therefore, between these two, the common multiple we're going to make use of there is 26. That means 26 comes out of these two, coming to meet this 2x minus 3. What am I doing right now? I'm trying to find the common multiple that I'm going to use to multiply every single term here in this equation so as to make the divisors become 1. Let's proceed. I said earlier that the common multiple for 2 and 26 is 26. Therefore, out of these two, we take 26 to meet this 2x minus 3. Instead of wasting time to look for the LCM of 26 and 2x minus 3, just get their product. Anytime you are confused as to what the LCM of two numbers is, when you are faced with using it to further your procedures in solving mathematics, simply don't wait for lowest common multiple. use any common multiple. And the easiest common multiple to get is just the numbers multiplying themselves. At this point in time, since we have 26 here between these two and this 26 here, let it meet these 2x minus 3. Therefore, the common multiple is going to be, look at it here, 26 bracket 2x minus 3. Otherwise, 26 times 2x minus 3. This has become the LCM. Even if you insist on working it out, you will see that this 26 bracket 2x minus 3 will also be its common multiple, or their common multiple. So far, did you understand what I did in choosing this 26 bracket 2x minus 3 as the common multiple of all these divisors? Please, if you did not, take your time to go through it again. Definitely you're going to get a sense of what I explained. Now we make progress. Now we have seen that 26 bracket 2x minus 3 is the common multiple of these divisors. Then we're going to use it to multiply this, and this. Then the next thing is going to be, first of all, that common multiple times this. The same common multiple times this. The same common multiple times this. This is where the common multiple is multiplying the first one. This is where the common multiple is multiplying the second one. This is where the common multiple is multiplying the third one. This way, we are trying to make the divisors become 1. Now let's proceed. We simplify each of these multiplications. We simplify this one, simplify this, simplify this. How is it going to be? When 2x minus 3 divides 2x minus 3, the answer is 1. That 1 times 26, then times 20, becomes 26 times 20. That means that 26 bracket 20 is the result of this multiplication. Let's now get the result of this multiplication here. When 2 divides 26, the answer is 13. 13 times 1, 13. Then times 2x bracket 3 will give us 13 bracket 2x minus 3. I hope you see and understand what happened here. Yes, I believe you have understood. Now, let's move to the third one, the right-hand side. Here we have 26 dividing 26 is equal to 1. 1 times 27, 27. 27 times 2x minus 3 is 27 bracket 2x minus 3. Therefore, in summary, both sides have been simplified, or they are undergoing simplification. This is the result of this. This is the result of this, while this is the result of this. Please check to be sure that you are following what is going on here. It's okay. Now let's move on. It is now time for us to apply another skill. We have just concluded with this D. We have just made the divisors become 1, meaning that there is no longer a fraction of something over something except over 1. Whenever 1 is the divisor, you see it that the divisor has been treated. And here, the divisors here are all 1. Because of that, we know, or we claim, that we have cleared the divisor. We've made it become 1. Now, earlier I said that there was going to be a need for unification, because in the beginning it was not easy to detect that this x would appear more than once, because in this equation, in the entire equation given to us to solve, it appears just once. Now, what is happening? after we have dealt with it to this level, notice that it appears here. It also appears here. That means that x, which is the unknown, now appears more than one place, making it necessary for us to consider unification. That means we are coming back to collect like terms or factorize, whichever way. We're going to ensure that that x, which appears more than once, is going to appear once. That process of making the unknown appear once is what we refer to as unification. That is U. It has become necessary at this point. But obviously, we can't start collecting like terms here. Why? There is an obstacle to collecting like terms. What obstacles could make collecting like terms difficult or even impossible? Obviously, the first obstacle we see is that if the unknown or the unknowns we want to unify are found in separate brackets, so when the unknown is a part of expression in an enclosed bracket and the bracket is not opened yet, it is an obstacle. This x is inside the bracket and the bracket is not opened yet. So when what we are looking for is inside a bracket, we cannot proceed except the bracket is opened. Don't forget that bracket opening is one of the skills we mentioned when we were outlining the skills needed for solving ordinary algebraic equations. It is time to apply it here. So these two x and these two x cannot be forced to go and meet each other. The reason is that the brackets are obstacles to them. Apart from brackets being obstacle, other things could be obstacles. Another one is a common power other than 1. If you have a power here, which is not power 1, it is also going to be an obstacle apart from this bracket we have here. Other one is going to be a common root. So common root, common non-1 power, and then a bracket. These things can make it difficult or even impossible to collect like terms. Here, only brackets are stopping us from collecting like terms. That means that the brackets must be opened. Watch how I open the brackets. We've learned before how to open brackets, and here I'm going to apply it. 26 times 20 is 520. 13 bracket 2x minus 3 is 13 times 2x, which is what? 26x. Then minus 13 times minus 3 will give us plus 39. Go back to where I taught how to open brackets, especially under the topic arithmetic laws. It is a lot of distribution that I'm using here. Remember the law of distribution or distributive law. This 13 is used to open this bracket by multiplying the contents of the bracket one after the other. This times this. Please be sure that as I'm multiplying, you recall that this minus is not subtraction. This minus is belonging to this 13. This 2x has its own sign, which is not written, but obviously because it is missing, it is plus. This minus does not belong to 2x, it belongs to 3. Therefore, this is minus 13 bracket plus 2x minus 3. Therefore, when this 13 is multiplying anything in the bracket, it is carrying this sign with it as it is multiplying. That means minus 13 times plus 2x. The answer becomes minus 26x. That's how this minus came here. It is not just because minus was here that it came to be here, but because minus multiplied plus. And according to our topic number 2, we recall that negative of having is owing. That's how it came to be minus 26. Not just because minus is here and so minus should be here. Now let's go on. Minus 13 times minus 3. This time around, it is negative of owing 3 into 13 times. The answer is what? Plus 39. I don't think I have to go in detail again respecting what is going on here. Please go back to arithmetic laws and you understand what is going on here. And then go back also to the principles of mathematical operations, topic number 2 in our series, and you now know what led to these signs being what they are at this level. All right, so far this has become this has become this. What about this one? The same thing. Please, what is here? Plus 27 is there. Plus 27 times 2x is plus 54x. 27 times minus 3 is minus 81. Because of that, all of this have come to be the result of expansion of these brackets. We now say that brackets have been opened. Students, is it now time to collect like terms? That obstacle, which was a bracket, has it been cleared? Surely, in this expression, there is no more bracket. That means it is time for us to start collecting like terms. Now we bring it forward. That is 520 minus 26x plus 39 is equal to 54x minus 81. This is the result we got after brackets were opened in the last line. We now see the obvious reason why we cannot proceed without collecting like terms. What is it? The x which we are solving for appears more than once. Until it appears once, we can't proceed solving for it. So at this point in time, the challenge we have is how to make this x appear just once. That means that 26x and 54x must be collected to one side and must be made to become one value in x. The simple truth therefore is that we're going to make x appear once by collecting like terms. How do we collect like terms? As a reminder, we collect like terms using two things in mind: additive inverse and the basic principle of solving ordinary algebraic equation. The principle states that any new operation that takes place in one side of equation which changes the value of that side must be repeated on both sides or on the other side of the equation to maintain equality. Then that principle is what we have to bear in mind whenever we want to collect like terms. Second principle is that whatever additive inverse of a number is added to it, the result is 0. And whenever a number becomes 0 on one side of an equation, the implication is that that number has disappeared from that side. For instance, if I add plus 81 to this minus 81 here, certainly this minus 81 has become 0. And once it is 0, it means that 81 has disappeared from right hand side. Therefore, the summary is, when collecting like terms, use additive inverses in association with the principle of solving ordinary algebraic equation. This I will do not step by step as we had learned earlier. In day-to-day solving of ordinary algebraic equations, collecting like terms one after the other is time consuming, energy consuming, and space consuming. We can collect like terms at once. How? Just don't forget, use additive inverse in association with the principle of solving ordinary algebraic equation. Therefore, it is either the terms in x stay in left-hand side and the constants stay on the right-hand side, or the terms in x stay on the right-hand side and the constants stay on the left-hand side. Any one that is done and is done correctly will lead to a correct answer. At this point, please, 520, which we are seeing here, this 520 we are seeing here is a constant. It must join with other constants. That is what we call collecting like terms. 520, 39, and minus 81 are like terms. They must be on one side of the equation, either left-hand side or right-hand side, while minus 26x and plus 54x must also be one side of the equation, either left-hand side or right-hand side. We choose to make the constants stay at the left-hand side, which means that 520 and 39 are already on the left-hand side. See me collecting them here. 39 is plus here. It is still plus here. Why? It did not cross sign of equality. It is just being brought nearer to this 520. But watch what will happen to 81. If you add plus 81 here, and it becomes 0, that same plus 81 must be added to the left-hand side. That is how this minus 81 became this plus 81 here, which means that it is as if minus 81 just jumped and came here. So whenever you hear teachers tell you, collect like terms, whenever a number crosses sign of equality, its sign changes. It is true based on the summary following application of what I told you is the method of collecting like terms, which is use additive inverse in association with principle of solving equations. The summary of that application is what I have here. 520, 520, 39, 39. Minus 81 from right-hand side has come to left-hand side to become plus 81. Now, what about 54, please? 54x. It is a like term to minus 26x. Because all the constants have taken the left-hand side region, it is this 26x minus that will transfer to right-hand side to join 54x. If we get the additive inverse of this minus 26x, it is going to become plus 26x. And see it here. That means it is just as if this jumped this equality sign and came to be plus 26x, giving rise to 520 plus 39 plus 81 is equal to 54x plus 26x. Like terms have been collected. So far, the summary is that 39 came nearer to 520 to become this, and minus 81 crossed this equality sign to become plus 81. This did not change its sign. This changed its sign. I hope you now know why. Likewise, this minus 26x will have to jump to right-hand side to meet this 54x. It is minus here, so it has become plus here. I hope you also understand. With this, the like terms have been collected. That is, constants, only constants without variables are on left-hand side. And all the things that contain x, the variable, are on the right-hand side. Let's now simplify both sides to see what results. 520 plus 39 plus 81 will give us 640. While 54x and 26x, when added, will give us 80x. Therefore, this will give us this, while this will give us this. Therefore, 640 is equal to 80x, or 80x is equal to 640. That means that both sides have been simplified. It is now as if what we have at hand is 80x is equal to 640. We are through with unification. Then to clear others, we have to clear others also by collecting like terms. It is as if this and this have been done together in one process. Now we are left with changing the changing the we are left with changing the coefficient to 1. And of course, you can see that what remains here is C. P is not going to be used because there is no power above 1 here. We go back to 80, x is equal to 640. What is now the obstacle? The x has 80 as its coefficient instead of 1. We now make it become 1 by saying 8 dividing both sides. When 80 divides 80, it is 1. 1 times x is this x here. When 80 divides 640, the answer is 8. I hope you know what brought this 80 here. Yes, my target is to ensure that this x has 1 as its coefficient. So this 80 came to achieve that purpose or to meet that purpose. And because it has come from outside, that is, this 80 had not been a part of the question we're solving, but it was brought in from outside to achieve a goal. Because this 80 will change the value of this left-hand side, it must also be used in the right-hand side as it is being used here. 640 over 80 is equal to 8. Eventually, this will give us x and this will give us 8. Therefore, the answer is that x is equal to 8.